Alright, so here in this particular problem, we have two blocks, both initially moving rightward. The block on the left is just mass m, whatever m is. It is moving at a rate of 2v naught, whatever v naught is. And then the block on the right is 3m, as shown there in the diagram, and is moving at a rate of v naught to the right. Okay, so in this system, you have both blocks initially moving rightward. They are going to collide and then stick. Okay, so this block here, because it is moving at a faster rate, will eventually catch up with the block on the right, and they will stick. Alright. Let's go and crack it up. It wants us to find the speed of the combined block, so I'm just going to go ahead and call the block on the left block 1. I want to call this block on the right block 2, just for the sake of subscripts. So I'm just going to set up conservation linear momentum. Net momentum initially equals net momentum in the final frame. Here, in this particular problem, you have two blocks. You have m and 3m, so I'm just going to set the statement on the left to equal to two terms. I have a momentum initially for object 1. I have an initial momentum for object 2. In this particular problem, both exist because both are initially moving. And then on the right side, you have two blocks that will move after the collision. So here I have P1F plus P2F. All right. So let's go ahead and expand these momentum term. Momentum by definition is just m times v. So if this is P1, I'm going to use m1. Once again, m1 being the block on the left, m2 being the block on the right. And then v1i, and then p2i can be broken down to m2 times v2i, and then likewise on the right side. But what I do want to point out is that the phrasing here in the statement, it says collide and then sticks. So this term or this word here, sticks, should trigger that you need to combine the masses on the right side of the function. So what I did was here for m1, I just replace it with m because that's what it is. I don't know what m is, and I don't care because eventually as you practice, you see that m here will cancel out. Here, what is the initial velocity of object 1? It is just 2v naught, so I just substitute in 2v naught. Likewise with m2, m2 is just called 3m, and then v2i here is just v naught, and that's positive, so both these terms for the velocity is or positive. So 2v naught is positive, and v naught is also positive because the diagram shows it. All right. On the right side of the function here, m1, I replace it with m, and then you notice here though, v1f is just now vf, because when objects stick together, they will have the same final velocity, and if they have the same final velocity, you no longer need to use ones and twos for the velocity term because it's the same. Here m2, I just substitute in for 3m, and then v2f just becomes vf once again because they're the same v. All right, I'm just gonna combine like terms real quick. I just rewrote the left stuff on the stuff on the left side just so it's easier to follow. So here you have 2 times mv naught, so I just wrote that as that. So I just wrote the coefficient on the front. Here is just 3m times v naught, so that stays the same. And then on the right side, what I did was I just kind of factored out vf here because both of these terms have a vf. So here I just set m, which is right here. You add it to 3m, which is right here, because they have, they have the same velocity, so you can just combine the two masses, okay? And then the vf stays on the outside of the parentheses. So if you combine like terms, you have 2mv naught here plus 3mv naught. That'll make a total of 5mv naught. And then the parentheses on the right side, m plus 3m, just becomes 4m, and then vf just gets carried down. But as you can see here, both terms have an m for mass, so we can just cancel out, okay? And then here, we're just left with 5v naught is equal to 4vf. So therefore, to get vf by itself, just divide both sides by 4. That's why the 4 is in the denominator in the next line there. And that looks like choice D. So that is it for this particular problem. Stay nerdy, don't be whack.